So probability, to calculate probability, it's all about fractions. So the thing about probability is you have to work in terms of fractions. So the correct fraction for probability when solving it, it is the desired outcome, so like what you want, over all possible outcomes. So the hardest part about probability is just trying to set the problem up. The problems most of the time are word problems, and on page 6 we have examples of how they're used on the ACT, like types of probability. But probability is just the desired outcome, which is like what you want, over all possible outcomes. So let's say you're getting dressed and you look in your closet and you want to pull a t-shirt. So you would have on the top how many t-shirts you have in your closet over all of the other clothes in your closet. So let's say you have 50 pieces of clothes in your closet. 5 of them are t-shirts. The probability of you pulling a t-shirt out of your closet is 5 over 50. You have 5 out of 50 to properly pull a t-shirt. The term probability could also be called, what are the chances of pulling a t-shirt out of your closet? Or what are the odds of pulling a t-shirt out of your closet? Or what is the likelihood of pulling a t-shirt out of your closet? These are all synonyms for the term probability. Chances, odds, likelihood. Those are the keywords you might see in a problem. It might not say what is the probability of this happening, but it might say what are the chances of this happening, or the odds, or the likelihood. The thing about probability is that it has to also add up to 100%. So probability will always add up to 100%. So what that means is if you have 5 out of 50 of your clothing pieces are t-shirts, that means 45 of the other 50 are other various items. 45 plus 5 is 50, so it equals 1 over 1. So the probability will always add to equal 1, so which means the fraction will always reduce to 1. If you find all of your probabilities and add all of your chances together, it will always add up to 1. You cannot have probability over 110, like over 100%. It can't say, oh, the probability of me picking up a highlighter and it being green is 110%. Like, that's not possible. It cannot be over 100. So any kind of answer choices on the ACT, if there is an answer that says the probability is 1.7, like, that's not possible. Probability always equals 1 or 100% total, if you're thinking in terms of percentages. Okay. So let's talk about some very common things that the ACT requires that you know. It requires that you understand coins, like a normal coin, dice, and a normal deck of cards. So a coin, a normal, just basic coin, is one option is head, one option is tails. So you can do heads or tails. It's not like a double-sided coin. So you have a 50% chance of flipping the coin and it being heads, 50% chance of it being tails, or 1 over 2, 1 out of 2 chance of it being heads, 1 out of 2 chance of it being heads. Like, there's only 2 outcomes with a coin. It's never going to land on its side where it's standing straight up, unless, like, it's no gravity or something. I don't know. It's not possible. Heads or tails. Dice. If you are working with a 6-sided die, this is how you call it a die, so I'll grab one. So here is the 6-sided die. Okay? You have to understand even and odds. So how many even numbers are on a 6-sided die?
3.
There are 3 even numbers, and there are 3 odd numbers. You have to make sure that you know that. Like, it's gonna ask you, on a normal 6-sided die, what is the probability of rolling an even number? 1 out of 2. Like 3 over 6, which reduces to 1 over 2. So you have to understand dice and how they work. Okay, you can't take one into the ACT. What about cards? A normal deck of cards is how many cards? 52 cards. How many suits? Suits are colors.
Oh, I thought suits were the spades.
Right? Suits are colors, aren't they?
I thought the suits were like the spades and bugs.
So what do they call the black and white? Okay, we'll break it down into... No, I don't know.
Pretty sure suits are like.
Is that ace?
Clovers and stuff.
Okay, so what do we call the color? I'm going to have to Google that real quick because I want to make sure that I'm telling you the right thing. Ready? Come here. Okay, so how many red cards are there? There's red and black. So how many red cards are there? How many black cards are there? Yeah, half and half. So there's 26 red and 26 black. So these are facts that the ACT expects you to just know. Like, we're not allowed to teach you about gambling and stuff, but they expect you to have an extensive knowledge of cards. Like, I don't know why. So they tell you that you have to know cards. So 52 cards, 26 red, 26 black. So the suits, they have clubs, diamonds, hearts, and spades. So we'll do spades here and hearts here. Yes, I did. Thank you. So there are 4 types of suits: the clubs and the spades. So clubs and spades, those are black cards. The clubs and spades are black cards. The diamonds and the hearts, those are red cards. Again, they just expect you to just have all this knowledge memorized. In each suit has 13 cards. There are 13 clubs, 13 diamonds, 13 spades, and 13 hearts. So each type of suit has 13. The way that cards go, it goes ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So that's kind of the order of cards. Face cards are usually jack, queen, and king. Sometimes they say aces are, but I would think face cards are just jack, queen, and king because they have faces on them. So it's not like, you're playing blackjack or 21, things like that. Like the ace doesn't represent a 1 and an 11. That's only like gambling, which we're not talking about because we're not allowed to talk about gambling. Because it's illegal to gamble in school because all of you are mostly underage. Underage. And it's in the policy that gambling is not allowed in school. It's on the write-up form, yeah. That you're not allowed to gamble. Technically, it's a write-up.
We used to play games like that though.
Yes, but you're not allowed to bet. So if money is exchanged, it's gambling. So it's not allowed. I don't know.
Trading loan cards.
These are called face cards. So this is just kind of how cards are set up. I do think it's kind of crazy that they expect you to understand all of these things about cards. It has been a long time since I've played cards. I didn't even know what suits were. So, struggle. So percent probability. These next 3 questions are going to involve percentages. Says, what is the chance of drawing an ace in a standard 52 card deck? So the first thing you have to remember is that the desired outcome goes on top and then all of the other possibilities go on the bottom. So how many cards total are in a normal deck of cards? We're not counting jokers. That's not there are 52, right. And there are 4 aces, 1 of each color. So 4 over 52 reduces to 1 over 13. You have a 1 out of 13 chance of reaching your hands into a deck of cards and pulling out an ace.
That's all we do.
For the most part, yeah. Probability is very easy, but it's something that we tend to forget how to do. Now, to make this a percentage, what you would do is divide 1 over 13 in your calculator. So if it says, what is the percent that this would happen? You would do 1 over 13 and multiply that by 100. Basically, just make it a percentage. Yeah, so about 7.69%. If it said round, it would be like probably 8%. You know, it depends on what the question's asking. So to make this a percentage, you would do 1 divided by 13, which is 0.0769, and you would multiply that by 100. So you would have a 7.69% chance of pulling an ace card. Now, you don't have to multiply by 100 if you remember the shortcut to percentages. So if we multiply by 100, you can just move the decimal to the right twice, and that is your percentage. So if you remember how to do that, that is percentage. But cards, they can be a little complicated. There's a lot of stuff on there, just to make sure that we understand like all the pieces, the types of cards, all that stuff. All right, so the next question says, what is the percent probability of rolling an even number on a 6-sided die? So here's a 6-sided die. We want to know the percentage of rolling an even number. Yeah, 1 out of 2. So to start it, we have 6 numbers on the dice. The numbers go from 1 to 6. So there are 3 even numbers, 2, 4, and 6. So this reduces to 1/2, which would be just 50%. Like hopefully we understand that that is just 50%. You have a 50% chance of rolling a dice and it being even or odd. So in this case, we're looking for even, so we have a 50% chance of it being even, depending on how many times we roll it. Okay. Probability is just a lot about thinking. What could happen? What is true here? All right, next one, it says, if you flip a coin 100 times, like a regular coin, like a quarter, and you flip it 100 times, what is the probability of it landing on heads on the 105th time you flip it? So I've sat there, I've flipped a coin 100 times. What's the probability of me landing it on heads? 50%. Yeah, it's 50%. Like, the coin does not remember that it was heads 25% of the time. Like, it doesn't matter. Every time you flip a coin, you still have the same new outcome every single time. Now, if it had said flipping heads in a row, that probability gets smaller. But it just said, I just want it to land on heads. I have a 1 out of 2 chance of it landing on heads, so I have a 50% chance. Each coin flip is independent of itself. Now, at the bottom, we'll talk about like overlapping and non-overlapping probability. But in this case, every coin flip is independent. It does not remember, oh, well, I've been heads the past 3 times. I should probably switch it to tails. Like, the coin does not think about that. It's just independent. You're just flipping the coin, and each time you have a 50-50 chance of doing it. Now, if it talks about in terms of in a row, then that's overlapping probability, which we'll talk at the bottom. So percent probability is like the easiest probability. What out of what? What are my chances of doing this one thing? Now, the 2 types of probability are either or, which is called non-overlapping, and combined and, which is called overlapping. Okay. So either or probability, you are adding. So it is the probability of either event. Okay? So what that's going to be, let's say you're getting dressed. Okay? You have to, let's say you have, 10 pairs of socks. And you don't want them to match. Like, you pull out one pile and you pull out of another pile. That is non-overlapping probability. The outcome of A over the total outcome plus another outcome of B over the total outcome. Now, when it comes to this, the best, let's say, a best scenario would be, okay, you go to your fridge. You would be happy if you pulled out a Sprite or a Mountain Dew. You don't care which one. So the probability of you reaching into your fridge and pulling out a Mountain Dew or a Sprite, that is non-overlapping because you'd be happy with either of that. You would be happy if you pulled out this or this. So since you have more possibilities, you have a higher percentage of pulling out a drink you would want to drink because you would be happy with either A or B outcome, either this or that. It doesn't matter. So your chances are greater of you actually getting what you want, you being satisfied with the drink you've chosen. Okay. When you are working with either or probability, you are to add the probabilities together because the denominators will be the same. Okay, you have 25 drinks in your fridge. You'd be happy with Sprite or Mountain Dew. There's still 25 drinks in there. So if it is either or probability, this is called non-overlapping because you're only choosing one. You would add the probabilities together. Like I'd be happy with this or this. I have more chances of selecting one of those drinks because I'm okay with both of them. Combined probability or overlapping is, okay, I'm going to go to my fridge. I'm going to go over to my fridge and I'm going to pick a Sprite and a Mountain Dew. I want both of them. What are the odds of that happening? That happening, this one after another, that probability shrinks. You would multiply the probabilities together. So combined or and probability, to find the probability of either event, okay, you would again take the outcome of A, like the first outcome, over the total outcome, times this other outcome of B over the total outcome. So if you want two things to happen, you have to multiply the probabilities together, which means your chances of completing this become slimmer because you have to do both of them for the probability. And when you multiply fractions together, the numbers continue to get smaller. So when it's combined or overlapping probability, meaning this has to happen and this has to happen, you multiply the probabilities together. So the hardest part about this probability is you have to ask yourself, when do I add and when do I multiply? So ask yourself what's happening. If this or this could happen, you add them. If you have to do two things, this and this must occur, then you have to multiply. So on page 6, there are 3 probability questions. There's a basic probability or probability involving ratios, and then how to alter probability. So take a second, work through those 3 problems, and see what we can come up with. So on page 6, work on 1, 2, and 3. All right, so number 2. What'd you guys get for the second one, the probability ratio? Get anything for number 2? Nothing? None of you picked anything for number 2? What'd you pick? B? That is wrong, you're right. You picked C? That's also wrong. What? The right answer is D. So let's talk about it. So it says the circle graph below shows the distribution of registered voters by age in this random community. Registered voters are randomly selected for this distribution to be called on for jury duty. So if you are registered to vote, you could be called to jury duty. You get an excuse from work, you would get an excuse from school or whatever, and you would go be on jury duty. So it says, what is the odds in the age range to not age range? So So the important thing about these kinds of problems is when we're working with ratios. It says in the age range, not age range. So what that means is when you're writing your final answer, the people who are in the age should go first. The people who are not in age should go second. And the way that you know how to set that up is just right here where it says in the age range to not in age range. That is how you set this up. Okay. Then it tells you the first person called to jury duty is in the range of 25 to 30 years old. So we are looking for the age range. Okay, in this case, the age range that we care about is 25 to 35 years old. That is our age range that we are looking for. So what percentage of people are in that range? What percentage of people are in the 25 to 35 age range? Yeah, 42%. It gives you the key. It's solid black, which means these people, 42% of them, okay, 42% of these people are in our age range that we care about. Well, how many people are not in that age range? Yeah, 58. You would just add all of these people not in the age range. So the rest of the people, 8%, 11%, 25%, and 14%. If you add all those ages together, you get 58%. So 42% of those people are in the age range, and 58% of those people are not. So to reduce this, you would just reduce the ratio. Let's say that you don't know how to reduce a ratio, and that's okay. The way that you would reduce it is you could make it a fraction. The first piece becomes the numerator of the fraction. The second piece is the denominator. When you type this into your calculator, 42 divided by 58, you get a decimal, math, enter, enter. We'll change it to a fraction, 21 over 29, and then you would just put it back in the ratio. So whenever you're working with ratios and fractions, the first number in the ratio is always the numerator of the fraction. So it might give you probability in terms of a ratio. All right, it was my computer up. There it goes. So it might give you problems like a ratio. To simplify the ratio, just put it in a fraction. The first number is always the numerator. The second number is always the denominator. So 21 to 29 is the correct answer. So working with ratios, the order matters when you are filling in the pieces. Okay? Caleb, yeah, that's fine. All right, last one, altering probability. This is kind of like when we were doing averages, like what is the probability that I will make, or not probability, what is the average I need to make on my test number 4 to get an average of a 95. Like this is the same kind of thing, altering probability. So it says a bag contains 12 red marbles, 5 yellow, and 15 green. How many additional red marbles must be added to 32 already in the bag? So the probability of pulling a red marble is 3 over 5. Did you all guess on this one?
What is the right answer?
The correct answer is G.
I guess.
You guessed, did you get G?
Because I just put like where it says 3/5, I turned it into a decimal.
Okay.
And then I put like the numbers into like that over there too.
Yes.
Down the closest decimal.
You are very close with your process. Very close. So there are 12 red marbles, there are 5 yellow marbles, and there are 15 green marbles. How many total marbles are in the bag? What does it tell you?
32.
There are 32. Now we want to pull out a red marble, right? A red marble. How many red marbles are in the bag?
Well,
There are 12. Okay, there are 12 red marbles already in this bag. Okay. So we know we've got 32 on the bottom because 32 represents the total. There are already 32 in the bag. But we want to know 12 over 32, that doesn't reduce to 3/5. We want our final probability to be 3 over 5. So we need to add some red marbles in there. And like Leah said, she added 18 to that and then divided. So I'm going to put an X up here to represent additional red marbles. Right? We're adding marbles to the bag. However, if we are adding red marbles in the bag, what do I also have to do at the bottom? Yeah, I've also got to add those to the bottom. I don't know what it is. I don't know how many I'm adding, so I'm going to keep them as the variable X. I have to add the same number of red to the top and add that same number of red to the bottom. Now you can just cross multiply. So 5 times 12 plus X equals 3 times 32 plus X. It's just cross multiplication at this point. Or you could plug in your answers and test them out to see if you get 3/5. Same thing. But if you prefer algebra, this is the way that you would do it. So you would cross multiply, subtract that, subtract, you get, am I crazy? I am. That is not 64. That is 96. I was like, that's not working out the right way. There you go. This should be 96. So when I subtract 60 to the other side, I would get 36. When we divide by 2, we get 18. That's better. So you could do exactly what Leah did, but instead of dividing by 32, you should have also been adding 18 on the bottom. Then it should reduce to the same number. So remember, when you're adding marbles to the bag, you have to add them to the top and the bottom. So the only thing that you messed up on your process was just keeping the bottom 32. But not bad. Yeah, guess and check. Yeah. Yeah, let me write you pass. Guess and check would be a great way to go on this problem. Okay. So what we're going to do now is a probability practice. Yep. So online, guys, your probability practice is posted.